Hi and welcome to day 6 of radicals. Today we will be dividing, not multiplying, fractions with a radical in the denominator. And in order to do this, we actually need to not divide, we're going to multiply. So we are dealing with binomial denominators today, which means I have two terms, unlike what we did the other day where we only had one term. And when we do this, we call it rationalizing. In order to do this, we must find the conjugate. Okay, and the conjugate of the denominator is what's already in the denominator, except we change the sign in the middle to its opposite. So my denominator here is 4 plus the square root of 11. My conjugate would then be 4 minus the square root of 11. Okay, so I'm going to multiply by the conjugate, and the conjugate would be 4 minus the square root of 11. And whatever I do to the denominator, I must also do to the numerator, so I have 4 minus the square root of 11 on the top as well. And because these are binomials, I need to throw my parentheses in, because when I multiply, I have to distribute. So 5 times 4 is 20. 5 times the square root of 11 is minus 5 radical 11. Over, on the bottom, I'm going to have to double distribute or FOIL. 4 times 4 is 16. 4 times negative radical 11 is negative 4 radical 11. Radical 11 times 4 is plus 4 times radical 11. And then radical 11 times negative radical 11 would be minus 11, because radical 11 times radical 11 would be 121. And if you notice, I have a minus 4 radical 11 and a plus 4 radical 11, and they cancel each other out. So I have 20 minus 5 radical 11 over 16 minus 11. So I have 20 minus, hang on. So I have, what's here? 20 minus 5 radical 11 over 5. And then I need to look and see, does 20, 5, and 5 have anything in common? And the answer is yes, they do. They all have a 5 in common. So we can reduce them all by 5. So I end up with 4 minus the square root of 11 over 1. So my final answer is 4 minus the square root of 11. It is just coincidence that my answer is the same thing that I multiplied by. That will not happen again that I know of. The whole point in multiplying by the conjugate is to have this situation happen. When you multiply by the conjugate, those middle terms always cancel out. Therefore, when we do these problems, we can take a shortcut and only do the F and the L when you FOIL. So for number 2, we have 6 over 3 minus square root of 5. So my conjugate here would be 3 plus the square root of 5. And like I said, put parentheses around everything. We have a binomial. Then we distribute. So 6 times 3 is 18. 6 times radical 5 is plus 6 radical 5. In my denominator, I just have to do the 3. So 3 times 3 is 9. My radical terms are going to cancel each other out, so my inside and outside I don't have to do. So I'm just going to multiply my 2 radical 5s together, and it becomes minus 5. And when I simplify, I will get 18 minus 6 radical 5 all over 9 minus 5, which is 4. Now I need to ask myself, do 18, 6, and 4 have anything in common? And the answer is yes. They have a 2 in common. So when I divide everything by 2, I end up with 9. Let's see here, 9 minus 3 radical 5 over 2, and we leave it as such. Number 3 is a little bit different in that my numerator is a binomial instead of a monomial, but I still find the conjugate, which becomes 4 plus the square root of 3, and 4 plus the square root of 3. So in essence, we are really just multiplying by 1 in disguise. That works for us a lot. So I'm going to have to FOIL the numerator. 2 times 4 is 8. 2 times radical 3 is plus 2 radical 3. And then radical 3 times 4 is plus 4 radical 3. And radical 3 times radical 3 is plus 3. In the denominator, I do not have to FOIL, only in the numerator. 4 times 4 is 16. And then negative radical 3 times radical 3 becomes minus 3. Combine like terms, so I have 8 and 3, which is 11. And then a 2 radical 3 and a 4 radical 3, which is plus 6 radical 3, all over 16 minus 3, which is 13. Then I have to ask myself, do 11, 6, and 13 have anything in common? And the answer there is no. So I am done. Sorry about that. Last problem. I look at my denominator and I find my conjugate, and my conjugate is square root of 7 plus the square root of 3. Put my parentheses in. Okay, now let's multiply. So radical 7 times radical 7 is 7. Radical 7 times radical 3 is plus radical 21. Radical 3 times radical 7 is another plus radical 21, because remember they're both under radicals, therefore I can multiply the two numbers. And radical 3 times radical 3 is plus 3. All over, in the denominator I can take the shortcut. Radical 7 times radical 7 is 7. Negative radical 3 and times a positive radical 3 is minus 3. So combine my like terms. 7 and 3 is 10. Radical 21 plus another radical 21 is plus 2 radical 21s. And 7 minus 3 is 4. Again, I ask myself, do they have anything in common, the 10, the 2, and the 4? And the answer to that is yes. They all have a 2 in common. So it becomes 5 plus radical 21 over 2. And that is my final answer.